Hey y'all, I'm Sam and I'm a pre-calculus tutor here on Wyzant. We're supposed to find the degrees of the vector's direction, or the vector direction in degrees. And the vector has the components -1 and 22. So first of all, what does this even mean? We're used to seeing the x-coordinate and the y-coordinate written in this notation, except we're used to seeing parentheses. So these little v kind of brackets indicate that we have a vector, which means something that has direction and magnitude. And the direction is actually that we've moved left by 1 and that we've moved up by 22. So this is how to interpret this notation. We could take it to a graph, which looks like this. Of course, x being -1 means we move to the left 1 and up by 22. This is definitely not to scale. And then I actually went ahead and connected it using this purple line to be our hypotenuse. And then I drew in this little angle, which I named b arbitrarily. You can call it whatever variable you want, but I'd recommend not x and not y, just because that'd get a little confusing. The last thing I've indicated here are my degrees. We typically symbolize the degrees around my quadrants as starting at 0 over here, progressing to 90, 180, which I didn't write, but 180, 270, and then 360. You can review the unit circle, or just remember that a circle has 360 degrees, so each quarter of said circle would have 90 degrees, and we just kind of start here. That's the convention. So prediction for this angle is that it might be somewhere between 90 and 180. So let's keep that in the back of our minds and see if we can sort of reason through it with a little bit more math. So if we want to find this angle B, we have a couple of side lengths of this sort of right triangle. Oh, and by the way, we know this is a right triangle because the y component and the x component are always perpendicular. So the opposite of B has the measure of 22, and adjacent to B has a measure of -1. And B is not a right angle, B is this interior angle, sorry. So if we know the opposite and adjacent, we could use maybe a trigonometric relationship, and this one's going to be tangent. The tangent of angle B is the same thing as the opposite side over the adjacent side. So ka toa, right? This is the toa part. And we know in this case, it's going to be 22 over -1 or -22 if you'd rather simplify it, but either way is fine. Now, we're interested in finding angle B, so we have to kind of undo this operation of tangent. And most calculators have something called the inverse tangent function, not to be confused with cotangent, which is the reciprocal of tangent, but rather undoing the tangent function. So we'd say B equals the inverse tangent of 22 over -1, and I get -87 degrees. You can probably tell that we're not done because I have a couple more rectangles covering the rest of our answer, but we also made a prediction, remember? We said that the angle should be somewhere between 90 and 180. -87 is going to be if you went from 0 and you went backwards, maybe to around here. Not quite sure, but something like that. And notice that this is sort of the opposite angle of the one that we're interested in. You can also remember that tangent has a period of pi, which means it's going to repeat, or sorry, 180 degrees in this case, which means it repeats in quadrants 1 and 3 and quadrants 2 and 4. So we don't quite want what's in this quadrant. We'd rather reflect it and find it in this quadrant. And all we have to do that is add 180 degrees to get into the proper quadrant that we're interested in. So when I did that, I got something like 92.6 degrees, but then we round to 93 degrees. All right, I hope that was helpful.